In the last session, we talked about different kind of trees and about what a node is, what are the basic concepts of trees. So in this lesson, we'll be mostly talking about tree traversals. So there are actually three basic type of three tree traversal presents. One is called in-order, pre-order, and post-order. Uh, so the what we said just now is we have three basic tree traversals. One is in-order traversal, one is pre-order traversal, okay, and another one is post-order traversal, okay. So let's say we have so I mean all these tree traversals depends on the position of the parent element. Let's take an example of a tree. So let's say I have this tree, something like one, two, then I have three over here, and I have let's say 4 over here and 5 over here, right? So let's say this is my parent, this is my parent tree. Okay, in order traversal, the parent node sits in between your left child and your right child. Like your parent node will be traversed after your left child has been traversed, then it will traverse the parent node, then it will traverse the right child. Okay, so in pre-order traversal, your parent node will be traverse fast, then it will be your left child, then it will be your right child. In post-order traversal, it will be your left child, then it will be your right child, then it will be your parent node. Okay, so if you look at the positioning of the parent node in order, it's between left child and right child. In pre-order, it's just before your left child, and in post-order, it's after your all the children's or all the childs are traversed. Okay, now let's print the inner traversal of the above tree. For inner traversal, let's say traversal starts with this node, so this being the parent. Okay, so it's go ahead and traverse to its left node. So now for this node, it will check, does it have a left node? So it has a left node. So it's gonna go ahead and check for this node if it has a left node or not. So it's find it does not have any left node. Okay, so now left has been explored, so it will come back and print its parent. It's gonna print its parent. So the parent is 4. Okay, now it's gonna go and check its right. For this, does it have a right node? So it does not have its right node, so it will come back. So here, now the left has been explored for this node, so it will come back and print its parent. For node 2, it's gonna check its right node. Okay, now on this node, it's gonna go and check its left node. So does it have any left node? So left node is null, so do nothing. Then it's come back and print the parent node. Parent node is 5. Then it will go and check the right node. So right node will find it as null. So it will come back here. Then again, it will come back to here. Now for this node, both left parent and right has been explored. So it will come back to 2. For 2 also, left parent and right has also been explored. So it will go to node 1. And now for node 1, all its left subtree has been explored. So it's going to print the parent. So once the parent is printed, so it will go to its right node. For right node, it's going to check, does it have a left node? So it will find null, so do nothing. Then it will come back and it's gonna print the parent node itself. So the parent node is 3, it's gonna print 3. Then it's gonna check does it have any write node. So write node is null. So this is where the execution will stop. The result will be our InOrder traversal. Okay, now let's look at the pre-order traversal of the above tree. Let's clean this a bit. Okay, uh, in the pre-order, we should print first the parent. So what is the parent value? So we'll go ahead and print the parent is 1. Okay, now we'll go ahead, go to the next node, to its left child. Okay, for this node, we'll first print its parent again. So we're gonna print 2. Now for this node, we'll check, go to its left, and we will again for this node will print its parent, and for this node we'll check its left is null, then we'll check its right, we'll check its left, then we'll check its right is also null, then it will come back, then this is gonna come back. Okay, so left has been, for this parent left has been explored, so this will go to right. Okay, and it's gonna, for this node it's gonna print the parent first, parent is 5. It's gonna check if there is any left node, so it does not have any left node is null. Then it will check again if it has any right node, it does not have any right node, so it will again come back to here, then it will come back to. Now for this parent, all the left has been explored, so it should go to its right node. Now for this right, we should print the parent. I mean, for this node, we will print the parent. Parent is 3. Okay, and we will check if it does it have any left node? No, then don't print it. Does it have any right node? No, then don't print it. And so finally, we'll get our pre-order traversal of the above tree will be 1, 2, 4, 5, 3. All right. Next one is post-order traversal. Let's see it in action. Here, the parent, this is my parent. Okay. Now, in post-order traversal, it will first go to its left child. Now for this node, it will check again its left child. Okay. So now it will check, does it have any left node? So it does not have any left node. Okay, then it will check again, does it have any right node? So it does not have any right node, so it will first check left, then it will check right, then it will check parent. So it will find parent as 4, so it's gonna print 4. Okay, now so left has been explored, now it will go back to its parent. Now for this node, left we have explored, but right we have not explored yet, so it will go to its right. All right. Okay, now we are on node 5. We are on node 5. For this node, it will again check if does it have a left node. So it does not have a left node. Does it have a then again right node? So it does not have a right node. Then go ahead and print the parent node. So the parent node is 5. So it's gonna print 5. Then for this node, left and right both are explored. Then finally print the parent. Parent is 2. Okay, so it went back and print 2. Now so 2, now it will go back again to the parent node 1. For one, all its left all its left subtree has been explored. So it will go and explore its right subtree. So it will come back to 3. So again for this node, it will check, does it have a left node? No. Does it have a right node? No. Then left, right, then parent. So parent is 3. So go ahead and print the parent. Okay. Now once the parent is explored, so left, right has been explored. Now it will again come back and display the parent. This will be the post-order traversal of the above tree. Studio, first create a node class which will represent a tree node. Okay, so it will be basically, we can say public class node. So this node, okay, so the node will have, every node will have data. So it will be basically public int data. Now, so it is a binary tree. So in binary tree, we'll have 2 childs. So we'll say node, public node. So it will be, one will be left child. Okay. And another one would be, let's say, right child. I'll say public node, right child. Now let's create a constructor for it. And we can pass the value of it. So let's say int data. Let's do it as this dot data equal to data. Right, so this is my tree node. Now let's create a class for the tree traversals. I'm going to create a new class. All right, so let's give it a name as tree traversals.cs, tree traversal.cs. Okay, so this will be basically a public class tree traversal, and we will be doing public. So I'll create a static method. Let's say the first one we are doing is InOrder Traversal. InOrder Traversal. Okay, so inside the InOrder Traversal, we are gonna pass the parent, or we can say it as a root node, root, and we should actually traverse through all the element. So we will be doing it in a recursive way. So how we can do it, in a InOrder Traversal, we need to go and get the left node for it. So if, we'll say, if root is equal to null, then go ahead and return it. So don't do anything. So in other cases, in InOrder Traversal, go ahead and explore its left child first. InOrder Traversal, so go to root dot left child, explore its left child, and once the exploration is complete, so go ahead, console dot write line, go ahead and write the parent data. So it will be root dot data. So this will be my parent data. So once the parent you have explored or printed, so we'll go to InOrder Traversal and we'll simply do root dot right child. Okay, so that's basically our InOrder Traversal. Okay, next one is the PreOrder Traversal. So let's go ahead and do public static void PreOrder Traversal. So we'll just pass here node root again. So it's the same thing. So if the root is equal to null, then return, don't do anything, equal to null, then return. Okay. In other case, in the pre-order, so we are actually printing or traversing console dot write line. Let's say we will be printing root dot data. Then we'll again do pre-order traversal. So this is the parent data we have already printed. We are gonna explore root dot left child. Okay, then again pre-order traversal. We are gonna explore root dot right child. All right, so that's my pre-order traversal. Okay, the next one is post-order traversal. Okay, so in case of post-order traversal, let's public static void. Let's say what we are doing here is post-order traversal, and we are passing here node root. Okay, we'll do if. So if root is equal to null, then return. Okay, so in post-order traversal, we are gonna explore. So post-order traversal, we are gonna explore first the left child. Okay, then let's go to post-order traversal. Then we are gonna explore the right child. Okay, next we are okay, so left child, right child we have explored. Then let's print the parent element, console dot right line, let's print it root dot data. Okay, so that's basically the code, all the code we needed. So let's go to our calling function or main method and test this if it's working as expected or not. Right, so I missed a semicolon over here. Let's print that. Okay, so in the void main, we will be creating the tree. So the tree what we will be creating, this will be something like this. So let's create this list. Okay, so we'll have okay, so how we can create it. So that's my node. So I'll say root node or only root equal to new node. So new node we can pass our data, let's say 1. Now for the root node, if you look at, so for this root node we have left child has 2 and right child has 3, right? So let's do that. So root dot left child equal to, so this is again it's going to be a new node, and this is going to be 2, and similarly root dot right child will be equal to new node, and in the right child will have 3. Okay, now let's look at the tree again. So in our tree, so root dot left child has 4 and right child has 5. Okay, so root dot left child dot, so this is again a node, so it has a left child is again a node, new node, this is going to be let's say 4. Okay, so root dot right child dot right child. Okay, so this is going to be left child because how it is inside our tree. uh, Root dot left child dot right child. Okay, right child is equal to new node 5. Okay, so that's our tree has been constructed. Now let's go ahead and print the tree. Okay, so I'll create tree traversal dot. So let's go ahead and first go in order traversal. I'll pass the root node and we can add a console statement just to differentiate. Console dot write line. So the first one we are printing is in order traversal. So this is my in order traversal. Okay, now the next one we are gonna have is a pre-order traversal. Okay, so let's print this. So pre-order traversal, we are gonna do tree traversal dot pre-order traversal. Okay, next one is post-order traversal. Let's print this post-order traversal. Okay, so we are good. So I'll just add. Okay, let's hold our control over here and let's run the program and see if it is working as expected or not. Okay, so we are printing. So in order traversal, if we let's verify our result. So if we look at, okay, so the in order traversal was 42513. Perfect. Now the pre-order traversal was 12453 12453, and the post-order traversal is 45231 45231. So this is the code. So this is for today. So we will be exploring the iterative approach of in-order, pre-order, and post-order traversal in our upcoming lessons.